CNT125, we're doing our design module here, network design module. We left off talking about IP address management, so super quickly, remember, these three concepts really do go together. As we get an IP address from our provider, we're going to most likely take that translated into a private scheme we use inside. So to do that, I'm going to do network address translation, and that's where I configure the router to translate that single IP from the ISP into whatever private addressing scheme I want to use. So remember your private IP address scheme that you're allowed to use, the private IP addresses that you're allowed to use, and then remember that most likely you're going to do network address port translation like we've been doing in our labs this semester to translate that single IP from the ISP into the scheme you want to use inside, and the router takes care of making that table, mapping the IP addresses inside from the users to the single IP address outside. And remember, port address translation, it keeps track of them by using port numbers. It keeps track of these these connections by using port numbers. The outside IP will be the same for everybody, but it uses a different port number to say, well, it goes to this host, this port number goes to this host, this port number goes to this host, and so forth. That's what the router is doing for you. And most likely, you're going to configure either the router for DHCP or have a DHCP server in there to hand IP addresses out. That way, the users are getting the correct IP address from the correct subnet that you want them to have. Phones are getting the correct IP from the correct subnet that you want them to have. Wireless users are getting the correct IP from the correct subnet that you want them to have, etc. That way the users do not have to do this or keep track of this, and you can make sure they're getting the correct addressing that you want. We also said inter-VLAN routing is really, now that I put all these pieces together, my switches are doing the VLANs for me, separating them out here. The trunk on the switch is tagging that traffic as to what VLAN it belongs to. And then when it gets to a router or something layer 3, it could be a layer 3 switch, that device now knows, oh, your traffic from VLAN 10, oh, your traffic from VLAN 20, oh, your traffic from VLAN 30. And it now can take those and go, you have not told me I can't let them communicate, so I'm going to. Or the router can, through access lists like we've done with the security lab, the router can be like, oh, no. The access list says, no, this communication cannot happen, or this protocol traffic cannot happen between these two VLANs, etc. So these pieces kind of all go together. The private addressing NAT DHCP, and then usually the inter VLAN with things like access lists. If I'm dealing with IP phones, think back to the IP phone chapter we did. There is a couple special concerns we need to think about. One is, especially on the phones we have in the lab room, we make sure that they have 2 ports. That way, one port can go to the switch and the other one, the PC, can plug into it. And that means we're using less actual data ports on the wall of an office or less switch ports in the closet. But I do need to make sure these are cabled right. If they're cabled backwards, neither are going to function correctly. Your PC and your phone won't function correctly. So I need to make sure these are cabled correctly. And if I'm dealing with switches in my network, I need to make sure the switches are capable of Power over Ethernet to power these phones, access points, etc. Okay? I need to make sure the switch is going to power these, in this case, these phones. Once my phones are powered and up and working, then I have different protocol traffic that's moving around between the switch and the phones. So this type of traffic, whether it's skinny or SIP, excuse me, and then the RTP traffic between the phones, I need to make sure my network is supporting that, making sure my network is allowing that, especially if I'm doing access lists. I need to make sure my network is allowing that traffic, and I might even need to make sure that it's secured. As we discovered, our phones were already encrypting all this, but on other networks with other servers, you might need to make sure that is occurring, that your encryption, the phone traffic is encrypted. If it's not, it's super easy to capture those packets, reassemble them with something like Wireshark, and listen to the phone call. It's super easy to do so. So I need to make sure that they're in their own VLAN. I need to make sure that the protocol traffic is encrypted, as well as the protocol traffic is allowed through access lists or whatever to traverse between those 2 phones. And I actually have this here as a reminder too, making sure maybe my datas are in one VLAN and my phone is in a different VLAN. So those 2 traffics are separate. We did that pretty much from day one when we did our phones. We put them in separate VLANs right off the bat. Is there other security concerns? Well, there's lots of pieces I've given you throughout the semester. We would need to start putting all these together now. We've put a lot of pieces together, but as a big picture, I need to think about putting all these together. Things like password policy would need to communicate to your users along with acceptable use. What is allowed, what is not allowed. Things like host firewalls in place and filtering maybe the really unnecessary traffic from your users. Maybe FTP, tell them that kind of stuff gets filtered right at the desktop level. And then I might even have a network firewall as well as filtering all of the traffic moving through the network. And I put a picture in there of literally the Windows firewall that we configured, and also the Fortinet 40 gate firewall that we configured in our labs as well. I would probably have both of those pieces going. On things like my switch, I might be turning off excess ports like we did, as well as I might even be putting port security on. That way it's limiting the number of MAC addresses on that port. That way if somebody tries to plug something else in or unplug their desktop computer and plug in their own laptop, that switch is going to recognize that there's a second MAC address in there and just shut that port down for security. With that, I'm also probably putting all these users and things in VLANs. Desktops in one VLAN, phones in a VLAN, wireless users and access points in another VLAN. When I'm dealing with wireless, I need to make sure my wireless is secure as well. Just like we did when we hooked up our access point, we made sure we had the SSID the way we wanted, but then we also made sure that we had encryption for those users. So even if you did capture the traffic, it's encrypted. You might capture it, but you can't actually read it. So having that encrypted also in its own VLAN, and then last but not least here, throwing access lists on to filter what different populations can do. What can the desktop users or employees do? Maybe a list of A, B, C, D, E, F, G. And then the wireless users or maybe visitors can do A, B. They can browse. And they can browse, that kind of thing. It's like I can browse, and if you can do it in your browser, great, because then it's encrypted. Or if you can't, too bad. So say do it at home kind of thing. And very much like we did in our wireless lab too. So I'm thinking about putting all of these pieces together when I'm doing my network. And in real life, more too. More than we have learned here, there's more pieces that are going to get implemented as well. But bare minimum, start pulling all these pieces together we've done this semester and putting them into play in your design. All right. The next podcast will be when I go over the design lab. So look at that under the do area for this week.